Hello students, welcome back to my YouTube channel. In this video, we will be beginning ionic equilibrium in aqueous solution. So this is basically the second part of our equilibrium, unit 12. We have already completed chemical equilibrium, and in this video onwards, we will be talking all the theories and questions related to ionic equilibrium in aqueous solutions, right? So now first we have to talk about solutions, right? So here solution is a homogeneous mixture of two or more substances. So this is the basic definition of solutions, right? In our first unit, we have classified everything around our universe into matter and energy, right? So let me talk about a little bit about the classification of our universe that we have done in our first unit. So the universe contains matter and energy. So we classified energy into kinetic energy and potential energy. Okay, again, if we define the term matter, it will be anything that has mass and occupies space, right? So now we can classify matter into pure substances and mixtures. Pure substances and mixture, right? And pure substances can be classified further into elements and compounds. And in mixture we have homogeneous mixture and heterogeneous mixture. Right. So here in this unit we are going to particularly talking about homogeneous mixture. In this particular video we will be particularly talking about homogeneous mixture. That homogeneous mixture is called solutions, right? Okay, now if we consider a solution can be made by mixing a solute and solvent. Solute plus solvent will give you mixture or solutions, right? Right. Now the solutions can be in gaseous state, it can be in liquid state, or it can be even in solid state, right? So for solid state solutions we have examples as alloys. For example, we have steel, bronze, brass. These are the examples for solid solutions. And liquid solution we may have salt solution, we may have sugar solution, and we may have acidic solution. We have a lot of solutions. In this unit we will be talking about aqueous solution. And for gaseous solution we have a perfect example, that is air. So air is nothing but a mixture of gases, right? Okay, now we will talk a little bit about this solute and solvent. Now solute is present in small quantities in a solution, whereas solvent is present in large quantities in a solution. So solute is present in small quantity, whereas solvent will be present in large quantity in a solution. Large quantity, right? For example, if you take sugar solution, we will just dissolve some amount of sugar into water, right? So here if you just take sugar solution, let's say this is sugar solution, it contain solute and solvent, right? So solute and solvent. So here the solute will be sugar and the solvent will be water. Fine. So now here in this unit we will be talking about aqueous solution only, right? So here we are interested in aqueous solution only. So in this aqueous solution we will be having solute as a solid or liquid. Now here the solute might be solid or liquid. We will not have any gaseous solute, and basically the solvent will be water. Solvent will be water. So when we dissolve these solutes into this solvent, so ions will be present. For example, if we consider the equilibrium reaction happening between Fe3 plus and thiocyanate ion, we can write the chemical equation like this. So we have Fe3 plus and aqueous, right? So here we are supposed to mention the physical state also, since we are studying physical chemistry, and then SCN minus. So we will get a complex Fe SCN 2 minus. So this will be a complex ion. So here if you try to write the equilibrium constant for this reaction, it will appear like this, right? So we can call it as Kc is equal to since the equation is already balanced, we don't need to bother about the coefficients because they are all 1. So here we can write like Fe SCN 2 minus, right? So in the numerator we are supposed to mention or write the concentration of the reactants, and then in the denominator we will write the concentration of the reactants. Fe2 plus and SCN minus, right? So this is our equilibrium constant. Now we will talk about some dissociation equations also. For example, if you consider NaCl, so NaCl will completely dissociate and give you Na plus and Cl minus aqueous. So here we cannot tell that equilibrium will be attained, since this is an irreversible reaction. Okay. So we are not interested in these type of chemical reactions. So we have to call a scientist called Michael Faraday. Right? So this Michael Faraday is a scientist who contributed to electrochemistry. That is our next topic. Not next topic. After studying phase equilibrium, we will move to electrochemistry. So here Michael Faraday classified substances into 2 categories, right? He categorized substances into 2 major categories. One is electrolyte and the other one is non-electrolyte. So electrolytes are the substances that conduct electricity in aqueous solution, right? So based on the ability to conduct electricity, he classified substances into electrolyte and non-electrolyte, and he told that electrolytes are the substances that conduct electricity in aqueous solution. So conducts electricity in aqueous solution, right? Okay. And conversely, the non-electrolytes are the substances that do not conduct electricity in aqueous solution, right? So here dot, right? So I'm just writing dot. Okay. Now the examples for electrolytes. Again, he classified electrolytes into two components. First one is strong electrolyte, and weak electrolytes. So strong electrolyte are the substances that undergo complete dissociation, right? So here strong electrolytes are the substances that undergo complete dissociation, and weak electrolytes are the substances that undergo partial dissociation. For example, here if you take an example for electrolyte, all bases and acids, right? So examples for electrolytes are bases, acids, and salt solution, right? So salt solution also contains ions, right? So it can conduct electricity in aqueous solution. And perfect example for non-electrolyte is sugar solution, right? So sugar solution does not conduct electricity, as sugar dissolves in water to produce sugar molecules, right? So since sugar solution does not dissociate into ions, it cannot conduct electricity. So this process is called solvation. And we are not going to talk about this non-electrolyte in this chapter, and we will be talking about this electrolyte and non-electrolyte in detail in our electrochemistry portion, right? Okay. Now we can classify these electrolyte into strong and weak electrolytes. So strong electrolytes are the substances that undergo complete dissociation. So for these strong electrolytes, we can give examples for as acids and bases. So it's not acids comma bases. Here strong acids comma strong bases, right? Because strong acids and strong bases undergo complete dissociation. And here weak electrolytes undergo partial dissociation, and we can give weak acids and weak bases as examples for these kind of weak electrolytes. Okay, right. Now we are going to move to strong electrolytes. Now I will explain you some theories related to this strong electrolyte and weak electrolyte, right? For example, let's say we take strong electrolyte. So strong electrolyte should undergo complete dissociation. For example, if you take NaCl is a strong electrolyte as it undergo complete dissociation as Na plus aqueous plus Cl minus aqueous, right? So here if you can take solid. Now again, if you take HCl can dissociate as H plus and Cl minus aqueous, right? So HCl aqueous. Now this equation or this chemical reaction can be written as HCl. Now if you dissolve HCl into water, it will produce H3O plus and Cl minus, right? Okay, right. Now these H plus ions are called proton, because why? In H plus, in hydrogen we have only one electron, and H plus is formed by removing or losing the solo electron in the valence shell of hydrogen. So this is nothing but proton, because in hydrogen atom we have only one electron, one proton, right? So now if you lose one electron, we have only one proton. So this basically H plus ions are called protons, right? Now this H3O plus is nothing but hydrated ion, right? So this is but nothing but hydrated proton, right? Because hydrated proton means a water added proton, right? So we have added water to proton. So this is nothing but water added proton, right? Okay. Now we will talk about weak electrolyte. Weak electrolyte. So weak electrolyte, weak acids and weak bases can be examples for weak electrolytes. Now I will just take the dissociation of acetic acid. So here we have CH3 COOH aqueous, and it dissociates as, let's say, CH3 COO minus aqueous plus H plus aqueous, right? Now I can write the same chemical reaction using this chemical equation as well. So now let's say CH3 COOH is dissolved in water, right? So now what will happen here, we will have CH3 COO minus, and here H plus is there, this is proton, and the proton will be hydrated producing H3O plus aqueous, right? So we can use these two equations to mention or write the dissociation of acetic acid. Now here what will happen is, initially we have CH3 COOH. Now gradually CH3 COOH will dissociate and produce acetate ion and proton, right? So H plus ion and CH3 COO minus ions. After some time, what will happen is some of the CH3 COO minus ions and H plus ions will reunite and produce CH3 COOH. So here an equilibrium will be established between the ions and the unionized molecules. So see, this kind of equilibrium happening between weak electrolytes is called ionic equilibrium, right? So basically we will be talking about weak electrolytes under ionic equilibrium. Now we will have to talk about acids, bases and salts, right? So this is very important topic. Here we have already studied some definitions for acids and bases, but here in this video we will be talking about three different definitions for acids and bases, and we will study a new concept called conjugate acid and conjugate base pairs, right? Okay, right. Now we will directly move to the important topic, acid, base and salts, right? So acid, base and salts. So what we have studied in our junior grades is, whatever the substance that is producing H plus ion into aqueous solution is called acid, and whatever the solution producing OH minus ions into the solution or into the aqueous solution is called base, right? So now this is called Arrhenius concept of acids and bases, right? So basically we will be talking about three different concepts for acids and bases. The first one is Arrhenius concept of acids and bases. Then we will move to something called the Bronsted-Lowry definition of acids and bases, and finally this is also not new to us. We have already studied about Lewis acid and Lewis bases in our second unit, which is bonding and structure. I think only the second definition will be new to you. So first we will talk about this Arrhenius concept of acids. So here Arrhenius is a scientist who came up with this idea or the definition for acids and bases. So he told acids are the substances that dissociate into water to give hydrogen ions, right? And the bases are the substances that produces OH minus to the solution, right? So here let me write down the definition for Arrhenius concept of acids and bases. So acids are the substances that produce or that dissociates or whatever that dissociates that okay that dissociates in water that dissociate in water to give H plus ions. And similarly, bases are the substances that dissociates in water to give OH minus ions. Right. Now we will just look at the famous example or the typical example that we have already discussed. So what we have already discussed is, for example, if you take HCl aqueous, now HCl will dissociate as H plus and Cl minus, right? So Cl minus aqueous. So now you see here in aqueous solution, it has left or it has released H plus. So HCl is called acid according to Arrhenius definition. Now if you take for example NaOH, now NaOH will dissociate as Na plus and OH minus, right? So here, since NaOH has released OH minus to the aqueous solution, this is called base, right? Okay, now even though this is an accepted definition, we have some limitations also. Now, for example, if you take ammonia, ammonia cannot produce OH minus. Anyhow, it is a base, right? So we have to have some alternative definitions or concept. So another concept was developed by two scientists named Bronsted and Lowry, right? So we are not going to talk about their originality and their personal lives. What we need is their definitions only, right? So here in Arrhenius concept of acids and bases, we have some limitations, right? Majorly we have we have two limitations. So we will talk about the limitations of this concept. The first limitation is they are applicable only to aqueous solution, right? So now for example, if you want to talk about BF3 in ammonia, so ammonia can be in gaseous state, so we cannot tell that in gaseous state ammonia will produce H plus or OH minus. In that context we cannot argue. So the limitation is this concept is applicable only to aqueous solution, right? So applicable only to aqueous solution. And the major limitation is they are not applicable to the substances which do not have OH group, right? Hydroxyl group. So not applicable to the substances which do not have hydroxyl group. For example, if you take ammonia we cannot tell, we do not have any OH group, right? So here we cannot tell whether ammonia is acid or base using this Arrhenius concept. So this is why we have developed another definition called Bronsted-Lowry definition, right? So the second concept for acids and bases will be Bronsted-Lowry definition. So the second one will be Bronsted-Lowry definition. Right. So the Bronsted-Lowry definition is applicable for determining whether a substance is acid or base. Now, what these two scientists told is acids are proton donors, whereas bases are proton acceptors. Right. So here you see we have H plus, right? So now here in some substances we do not have OH minus, hydroxyl group. So now leaving O hydroxyl, now we are going to develop a definition only based on only H plus, right? So now we will call this H plus as proton, and what they told is acids are proton donors. So this is nothing but the first statement of Arrhenius concept, because we have already told that acids are the substances that dissociate or that gives. So we have already told you that acids are the substances that give, right? So that give H plus mean they donate, right? So they donate. So we can tell acids are proton donors, whereas the bases are the proton acceptors. Bases are proton acceptors. Right. Now, if you look at an example, let's say we have HCl and we dissolve HCl into water. So now we can tell that the products will be H3O plus and Cl minus. Now, as you can see here, this HCl will dissociate as H plus and Cl minus, and this H plus is given to H2O, which means this HCl donates H plus to H2O. So according to Bronsted-Lowry definition, what we can tell is this HCl is donating H plus, hence it is called acid. And since H2O is accepting proton, this will be called base. That's all. And if you look at another example where we dissolve ammonia gas into water, so ammonia aqueous plus water H2O will produce as NH4 plus OH minus, right? Okay. Right. Now here you can see what will happen is this H2O will dissociate as H plus and Cl minus, and this H plus will be donated to ammonia. So this H2O is called acid. Since it is donating a proton, this will be called acid, and since ammonia is accepting proton, this will be called base, right? So here you can see now what you have to notice here is H2O is acting base when it is reacting with an acid, and H2O is acid when it is reacting with base. So this is called amphoteric property of water. So here water is acting as both base and acid. Moving to the third definition of acids and bases, Lewis acids and bases. Right. So the third one or third definition will be Lewis acids and bases. Now here we have already introduced Lewis acids and bases in our second unit also. So what we learned there is, now if you have electron deficient molecule, now here this will be constructed, this definition will be constructed based on electron pair donation, right? So now what we will say is um, now here if I explain you using an example, then you can easily understand. Now let's say we have BF3 and NH3, right? So it will give you BF3 and NH3. Now BF3 NH3 BF, I can write this way. F3 B NH3. Now here if I draw the structure of BF3, it will be like this: BF3 and NH3. Right, now here we have an empty orbital in boron and we have a lone pair in nitrogen. So this nitrogen will be giving this pair of electron to boron to make a bond, and this will be called dative covalent bond. We have already studied there. And this ammonia is Lewis base, right? So we can tell a species that donates electron pair will be called Lewis base, right? So the theory that you should know is species that donates electron pair will be base, and the species that accepts electron pair will be called acid, right? So here ammonia will be base and Lewis base we will call Lewis base, and BF3 will be Lewis acid, right? Now here we can apply these Lewis acids and bases to the electron deficient molecules and ions and molecules with lone pairs. For example, if we have AlCl3, cobalt 3 plus, magnesium 2 plus, so these now AlCl3 is a molecule and cobalt 2 plus, cobalt 3 plus, magnesium 2 plus, these are the ions having electron deficiency, and here we can call them as acids as they are accepting electron pairs. And in this case water, ammonia, OH minus, these will be called bases since they are donating electron. So if you look at examples for these, so we can tell electron donating pairs, right? So water can come, OH minus can come, and ammonia can come, right? So since they are having lone pairs on them, right? Okay, and here we can tell AlCl3 and cobalt 3 plus, Mn2 plus, since they have empty orbital in their energy levels, right? Okay. So in this video I have explained you completely about the three concepts of acids and bases. Hope you enjoyed this video and got some information about ionic equilibrium and the three concepts of acids and bases. Hopefully in the next video we will be talking about conjugate acid base pairs and ionization of acids and bases, and from that we will be talking about KSP and other stuffs also. So please share this video with your friends also, and don't forget to subscribe to my channel, and until I meet you in the next video, bye.